Hi everyone, I am Faiza Maksusi. I hold a master's degree in biomedical engineering from Polytechnic Tehran in Iran, with a focuses on fMRI, neuroscience, and AI. My research interest and background focuses on enhancing MR images using deep learning method. And today I will introduce gradient descent and PyTorch autograd essential for training neural network. Okay, in deep learning, the goal of training is to minimize loss function and measure up the gap between predictions and actual outcomes by fine-tuning parameters like weights and biases. Actually, gradient is the key algorithm here. It calculates the gradients and showing how loss change with each parameters. And since the gradient indicates the sharpest rise in loss, we adjust parameters in the opposite direction, allowing the negative gradient in a smaller step to reach the minimum. For simple models, you could compute this by hand, but in complex neural networks with many layers, it's nearly impossible. It's when Python autograde helps. Actually, it's an automatic differentiation tool that computes gradients effortlessly. Actually, autograde builds a computational graph during operations on tensors, tracking everything like multiplication or addition. And I would say in the forward pass, data flows through and graph records it. And in the backward pass, autograd uses the chain rule to calculate gradients of the loss for each parameters. And you should define the forward computation and loss set requires grad to true for tensors, and autograd tracks gradients automatically. Okay. Um, Here in the coding exercise, we create a simple graph class with weight W and bias B. And both bits actually requires grad to true. For forward method computes actually W multiplied by X plus B applies tangent probability for a prediction. And then actually this loss SQ loss method calculates a squared error calling backward on the loss triggers autograde to compute gradients for weight and bias step. Let's do it. Let's check. X multiplied by weight plus weight plus X and here we should find one. That's right. Thank you for your attention.